channel, The Classroom. We are back with a new chapter, that is, you can see written over here, that is Exponents. This chapter is of Mathematics chapter of class 8. Now this particular chapter is very important in the sense because class 6 and class 7 is also having this particular chapter. Okay, so please watch the whole video because it is very important, and we are going to use this particular chapter of Exponents all throughout in many chapters. Okay, so please have attention. Next, the chapter's name is Exponents. Now what is the meaning of exponents at first? It means power. It means power. Okay, now I'll give you a short example of it. That is, suppose we have a to the power m. Okay, so a here is known as the base and m here is known as the power or exponent. Okay, so a is the base and to this power is known as the exponent. Okay, you can either use the term power or the term exponent. Next, coming to one more small property of it. That is, suppose you are writing a to the power minus m. This is a negative power that this base is having, right? So to make it positive, we take the reciprocal of this particular number and we get a positive power. Whenever we have a negative power, we take the reciprocal of that number, okay, to get a positive power. I hope I'm clear with this. Again, suppose I am having this 1 by a to the power minus n. Okay, this is already in the reciprocal form. To get a positive power, that is a, n, only n, not minus n, we will take the reciprocal of this particular number again. That is 1 by a to the power minus n. In that case, we will get a to the power n. The result will be that is a to the power n. If we take the reciprocal of this negative integer again, or negative number again, or with the negative power rather, we will be getting a positive power. Integer with a positive power. Okay, so whenever we take the reciprocal, we get the opposite signs. Suppose we are having a to the power minus p over here. Okay, let's take as plus p here. Okay, so if we take the reciprocal, we will have the negative power here. Integer with the negative power. Okay, again, or suppose I am having 1 by a to the power q here. Okay, if we take the reciprocal again, we will have a to the power minus q. That means whenever you are taking, in simple sense, whenever you are taking the reciprocal of a particular number with a power, the power's sign gets changed. Plus becomes minus, minus becomes plus whenever we take the reciprocal. I hope it's very clear with this particular examples. This is one example, this is one example, this is one example, this is one example. Okay, so these are different types for you to understand. Okay, we will be applying these in the calculations. I hope it's very clear to you, right? Next, we are going to directly come to the laws. Okay, that will make you understand. Suppose a to the power m into a to the power n. As you know, these a are known as the base and the powers of one a to the a is m and the other is n. Okay, so in this case, whenever the bases are equal and there is a multiplication sign in between, the powers get added up. A to the power m plus n. Example of this is 2 to the power 3 into 2 to the power 2. Okay, bases are equal, multiplication sign in between. We get the powers to be added up. 3 plus 2, that is 2 to the power 5. I hope I'm clear. This is the first law. Second law, this is the, let me write, law of exponents. Okay, next, a to the power m divide a to the power n. Okay, so we have here a to the power m minus n. Okay, so here again you can see bases are equal, division sign in between, the powers will get subtracted. Okay, powers will get subtracted. So example for you again, 2 to the power 3 minus, or sorry, divide 2 to the power 2. That gives you 2 to the power 3 minus 2, that is 2 to the power 1. 2 to the power 1, you know, that is 2. Okay, so these are very two most important laws. We will come more with other laws also. A to the power m into a to the power n. Bases are equal, multiplication sign in between, powers will get added up. Bases are equal, division sign in between, powers will get subtracted. This is it. Okay, next. Third law, we are coming to it. A to the power m to the power n. Okay, what happens is the powers get multiplied. Example, 2 to the power 3 whole to the power 3. Okay, powers will get multiplied. That means 2 to the power 3 into 3, that is 2 to the power 9. Hope it is very easy and clear. Next, the fourth one, a to the power m into b to the power m equal to ab to the power m. Okay, how? What is the example of this? You said, I have said before only, you might say, you have said that powers here, the basis has to be same, powers get multiplied, then added up. How come here a to the power m into b to the power m is ab to the power m? Now, small example to make you understand. 2 to the power 2 into 4, let me take some other digit, 3 to the power 2. Okay, this is giving you what? This is 4, this is 9, right? This is giving you 36, right? So that is equal to 6 whole square, right? Now if this is a to the power m and this is b to the power m, we are getting ab. This is also can be written as 2 into 3 to the power 2, right? So here this is an example which you can tally with this law. A to the power m into b to the power m, that is equal to ab to the power m. So 2 square into 3 square is giving you 2 into 3 whole square. Okay, this is a particular example of this. I hope it is very clear through it. Okay, you can easily go through this. Next, fifth rule. A to the power m divide b to the power m, that will give you a by b to the power m. Okay, so let's take a to the power m as 2 to the power 3 divide 3 to the power 3. Okay, so taking this as, that means you can check here, 2 to the power 3 divide 3 to the power 3, that is equal to 2 by 3 to the power 3, right? You can simply understand, this is a to the power m, this is b to the power m, right? So this comes, 2 by 3 whole to the power 3. This is another law. Example is given to it, you can go through that. Okay, next, have come with a solved example. You can check here. Okay, so that it becomes easy for me to make you understand. See, the question is 2 by 3 to the power minus 1 minus 2 by 5 to the power minus 1 whole bracket to the power minus 2 divide 3 by 4 to the power minus 3. Okay, now the thing is, first, as you know, here there is a negative power. That means we have to make this positive. To make it positive, we take the reciprocal. So it is 3 by 2 to the power 1. Okay, we have just taken the reciprocal. That means the digits will get reversed. Then 2 by 5 becomes 5 by 2 for making this power positive. Whole bracket to the power minus 2 divide 4 by 3 to the power 3. Why again? Because here it was a negative power. We have just taken the reciprocal to make the power positive. I hope it's clear, the second line. Now, next, the third step. Take don't have to think of this negative power right now. First, take out the LCM of these two numbers. Okay, that is 2, and subtract. Okay, so 3 minus 5 to the power minus 2 divide. As you know, this is a particular law that we have. this particular law is, that is a by b whole to the power 3. That means a to the power 3 by b to the power 3. That's what I've written, right? Next, so you're getting minus 2 by 2, that to the power minus 2, divide 4 to the power 3 by 3 to the power 3. Next, after this I've given a star mark here because I've come here because there was no more space. Next, so minus 2 by 2 is giving you minus 1 to the power minus 2, divide 4 to the power 3 by 3 to the power 3. Now minus 1 by 1, I'm just taking the reciprocal of this particular number to make the power positive. As you know, 1 by 1, and since here the power is 2, that means an even power is there. That means minus 1 into minus 1 will give you 1, right? A positive number, that is 1. So after division we will take the multiplication, as you know. So it gets reversed, 3 to the power 3 by 4 to the power 3. So on calculation you have 3 by 4 to the power 3, that means 27 by 64. So this particular thing is the answer. So for this question, this is the answer. This is how you're going to solve it. You can go through the steps, and if necessary, okay, like here we are taking the positive. So here in the reason you can write what is the reason behind this, because a to the power minus m equal to 1 by a to the power m. This you can write it. That means we are taking the reciprocal. This is the step of that. Here, how is it we are getting that this? Because a by b to the power m equal to a to the power m by b to the power m. So this is it. Okay, this is a reason for this. This is a reason for this. Okay. So I think easily you can go through this part. Okay. Next, it's better if you write these reasons at the side as per the rule. Okay. Next, we're coming to the second example. Next, I've come up with another example. Second example, that is 2 to the power minus 3 into 3 to the power minus 4 into 2 to the power minus 1 into x to the power minus 2 divided by 4 to the power minus 6 into 6 to the power minus 6 into 2 to the power 0 into x to the power minus 1. This is a particular question you have to simplify. Okay, next. So, coming to it, 2 to the power minus 3 into 3 to the power minus 4, 2 to the power minus 1, x to the power minus 2. I have kept this as same. I have not changed anything. But the denominator portion, 4 is multiplication of what? What are the lower terms of it? Factors 2, right? So that means 2 square, 4 is equal to 2 into 2, right? That means this can be written as 2 to the power 2, right? So I have written 2 to the power 2 whole to the power minus 6 into 6 means what? Factors of it is 2 and 3, right? So I have written 3 into 2 to the power minus 6. 2 to the power 0 is what? 1 and x to the power minus 1. Okay? Next, 2 to the power minus 3 into 2 to the power minus 4 into 2 to the power minus 1 into x to the power minus 2. I've kept this constant again by this, you know, the powers get multiplied. So here you can simply write again the reason as that a to the power m into n is equal to a to the power mn. This is the reason. Okay, so 2 to the power 2 into minus 6 to the power minus 12 into this also, you know, this 3 to the power 3ab to the power m is a to the power m, b to the power m. That's what I've done. 3 to the power minus 6 into 2 to the power minus 6. 1 I have just multiplied, so you're getting x to the power minus 1. Okay, next, we know that whenever we are taking these up, that means the signs will change, right? From like taking the reciprocal or from division to, that is whenever there is this is a by symbol, that means it is division symbol, we are taking this up, that means signs will change, right? So 2 to the power minus 3, this is going up, that means minus 12 will become plus 12. Then again this is minus 1, I've written there, and this is again 2 to the power minus 6, going up means plus 6. Okay, now into 3 to the power minus 4, here it is minus 6, going up means plus 6, into x to the power minus 2, and this is going up means plus 1. So you are having, the next step is here, I've put a star mark here, 2 to the power 14, calculate these powers and see what it is coming. Please be careful with the signs. 3 to the power 2 into x to the power minus 1. So I have just rearranged and written in this way. If we are writing this as the last answer, no problem, it's nothing wrong. Okay, that is also correct. But since it is said simplify, I have brought it to this particular step. I hope I'm very clear with this. Please go through these steps. I think it will be very much clear to you. Okay, you can just rewind and see it. Next, coming to the third example. Now, I've come up with the third example. 2 by 9 to the power minus 8 to the power minus 2 into 4 by 27 to the power minus 4 to the power minus 3 to the power minus 1. Now, the second step, 2 by 9, as you know, the powers will get multiplied. So, minus 8 into minus 2 will give you plus 16. That's what I've written, into 4 by 27. This is coming to minus 1 into minus 3. That is giving you 3 plus 3 plus 3 into minus 4. You're getting minus 12. Okay. Now, simply algebraic functions you can use for these multiplications. Now, 2 by 9 to the power 16 into 27 by 4 to the power 12. I've just reversed it, okay, taking the reciprocal to make it a positive power. Next, 2 by 3, 9 you know is 3 square, 3 into 3, so I've taken 3 square, okay, to the power 16 by 3 square whole to the power 16 into 27 is 3 into 3 into 3, right? The factors are 3 into 3 into 3, so 3 to the power 3 whole to the power 12 by 2 square whole to the power 12. 4 is 2 into 2, the factors. Next, after this step, put a star mark here. I have come to here. You can see. So it is coming to the power 16 by 2 into 16 is 32. So 3 to the power 32 into here 3 into 12 is 36. So 3 to the power 36 divided by 2 to the power 2 into 12. That is 2 to the power 24. Now simply rearrange 2 to the power 16 by, I have just brought this here, 2 to the power 24 into 3 to the power 36 by 3 to the power 32. Now you know that you're going to just subtract, thinking this to be the division sign. You know that these are going to subtract. This is a positive power. Going up, it becomes negative into 3 to the power 36 minus 32. 2 to the power minus 8 into 3 to the power 4. Just rearranging, I got 81 by 256. So this is the whole process of this example. I hope this is also very clear, should be very clear to you. Now, let's start with the expanded form of decimals and the standardized form of decimals. Okay, so first let me start with the expanded forms. Okay, so let's take for example 3204. Now this is, before in the lower classes we used to do this, right, in the expanded form. 3000 plus 200 plus 00 plus 4. So if you are writing this in the, that is in the power form, that means 3 into 10 to the power 3 plus 2 into 10 to the power 2 into, this is already, sorry, this should be plus 0 into 10 to the power 1 plus 4 into 10 to the power 0, because 10 to the power 0 is 1. So we are going to write the expanded form in this way. Okay, so let's take for a decimal number 321.29 suppose. Okay, so we are having 3000 plus, sorry, this is 300 plus 220 plus 1 plus 0.2 plus 0.09, right? This is what is the expansion form. For this is 3 into, let's write in the power form, 2 10 to the power 2 plus 2 into 10 to the power 1 plus 1 into 10 to the power 0, 10 plus 9 by 100. This is the expanded form. Now, to make it more suggestive, plus 2 into 10 to the power 1 plus 1 into 10 to the power 0 plus this you can write 2 into 10 to the power minus 1, right? Because it is here 10 to the power 1. So when we are bringing that in the upper, that is in the numerator part, that is taking the reciprocal, the power will get negative opposite sign, because here down it was positive. As we take that up, it will become negative, plus 9 into 10 to the power minus 2, because 100 means 10 square. So that means whenever we are putting that in the numerator, it becomes 9 into 10 to the power minus 2, right? So this is what is the expanded form of the numbers, how we write it. Okay, go through that. I think it will be very easy and simpler. Okay, next, coming to the standardized form. Now, coming to the standard form, I have taken one example, 0.000005 zeros, 1, 3 equal to, then see, how many zeros are here? 1, 2, 3, 4, 5, 6, 7, right? That means 7 zeros we have to write. 13 divided by 1 and then 7 zeros. Okay, so we are having 13 by 10 to the power 7, right? that is equal to 13 into 10 to the power minus 7. This is how we write the standard forms. Okay. Next, I have told of comparing two numbers. Now, the radius of Saturn is 6.02 into 10 to the power 7 meter and the radius of Earth is 6.3 into 6 meter. Okay. So, what I did is I have taken it in the division form. Radius of Earth by radius of Saturn is equal to 6.3 in 10 to the power 6 by 6.02 in 10 to the power 7. You might be asking why not radius on top, Saturn on top and radius of Earth. You can do the same thing, doesn't matter. Okay, answer will be same. So after calculation, you can see simply I've taken the normal calculation which I've shown before only. We have done this before. We have got the answer as 0.0104. So here in respect, radius of Earth is 0.0104 times of the radius of the Saturn. Okay, and if we write in the other way around, that is radius of Saturn up and radius of Earth down, we will get as that is radius of Saturn is 10 times of the radius of the Earth. Okay, you can simply use this. You can write this also, you can write this also. That is, if you are writing the radius of Saturn up and then divided by radius of Earth, you will get this directly. That is, you will get 10.4. Okay, so there you can simply write that is, it is 10 times, that is radius of Saturn is 10 times the radius of the Earth. Both of the answers are correct. Doesn't matter. Don't have to think so much. Both of the answers are correct. If you are writing that, just to the last line you do write radius of the Earth is 0.0104 times the radius of the Saturn. And if you are getting this as an answer, that is you are writing, then you write radius of Saturn is 10 times the radius of the Earth. Both are correct. Next, coming to the last portion of Exponent chapter, that is how to add or subtract any two large numbers like this. Okay, the problem size. Now, coming with the second example, as I said, this will be the addition one. The mass of Jupiter is 1.9 in 10 to the power 27 kg and mass of Sun is 1.99 in 10 to the power 30 kg. Find the total mass. So, accordingly, we have written the statement, mass of the Jupiter is 1.9 in 10 to the power 27 kg, mass of Sun is 1.9 in 10 to the power 30 kg. And total mass will be adding these two, 1.9 in 10 to the power 27 plus 1.9 in 10 to the power 30 kg. Now, you can see from this 10 to the power 27 and 10 to the power 30, common is 10 to the power 27. So, if we take 10 to the power 27 common, we will be left with 1.9 plus 1.99 into 10 to the power 3. This 10 to the power 23 you can just simply multiply and see. 1.9 plus 1990 you can add and you will get 1.9. How we are getting it? 1990, 1.9, we are getting 1.9. Okay, into 10 to the power 27. So this will be your answer. If this was given for the subtraction, find their difference, you will be doing the subtraction here. Same thing. Okay, nothing more than this. This is a very, suppose this particular sum is not given to you. Problem sum is not given. Only this portion is given. Okay, you will be writing in this way only. So in that time there will be no unit, no need of writing any statements. Only the sum you will be doing. I'll show you one more sum like this only with this particular sum of division. Now, I said only that portion will be given and with a division sign. So you are having 0.012 into 10 to the power minus 41 divide 0.003 into 10 to the power minus 46. So you are getting 0.012 into 10 to the power minus 41 divide 0.003 into 10 to the power minus 46. So as usual, you know that we can write 12 by 1000 into 3 by 1000. 1000 is going in the numerator into 10 to the power minus 41. This, if it goes in the numerator, it becomes plus 46. So you are having, you cancel out, you simplify, you see you will get 4 into 10 to the power 5. So this is the ultimate answer. So if you are not having any problem sums, you can also solve in this way. Okay, it can be plus, it can be minus, it can be multiplication also. Okay, in case of multiplication, suppose this was a multiplication, this particular one was a multiplication. In that case, whatever you multiply, then this 10 to the power minus 41 will get multiplied 10 to the power minus 46. Okay, so in this case, it will be bases are same, multiplication in between, that means 41 minus of plus of minus 46. So you are getting 10 minus 41 minus 46, 10 minus 87. So this is for your multiplication, the value of 10 to the power, the powers. Okay. So, and here it will be whatever the multiplication is coming to. This is coming to 0.01 to 12 into 3 is 36, as you know. 36 and whatever 10 to the power, whatever powers, and here the power will change. Okay, suppose here it is coming to 0. How many 3 zeros? That means 1, 2, 3, 4, 5, 6. Let me see, 1, 2, 3, 4, 5, 6. No, that means 1 0 will be less. So you're getting here 1, 2, 3, 4, 5 and 6. So you're having this into this. That means answer will be, if you write over there, 0.0000 into 10 to the power minus 87. If you write this, this also can be correct. Okay, so this is for your division. Multiplication, I have just told you. Here the two tens will get added up only. Okay, so this is the chapter of exponents. We have completed it. If you go through these twice or thrice, you can easily understand. It's not even tough. And please practice the sums that are there in your book, be it CBSE or ICSE. Okay, any book you can use and follow. And this was the last one, because I said class 6 and 7 is also having this chapter. But yes, this portion is not there till the before this comparing and expansions. The chapter is there for them, for the laws and all. So please be very careful with this chapter, because you will be needing it in the other classes or other chapters even. So let's say that we have finished this. And yes, if you're having any doubt, please comment so that I can solve it for you. And if you like this chapter, please do like, share and subscribe. Thank you. Have a good day.